Microremediation response teams. I bring this up in a very generalized way because if we are going to put people in these situations where they are going out, cleaning up the stuff, they have to know the risk. Environmental risk, public health risk, but also legal and liability risk. You know, there's regulations that say if you go into a spill and you try to do something, the moment you touch it, you get that liability. You're responsible for that spill now, for that contaminated site. Now it changes, obviously laws in different states are different, but that's a trend that's coming up. And you have to be aware of those at the very least. Be aware that there is a risk. Not just that published the paper didn't think so. So what is success, you know? There's some strategies that we can take, bioassays, toxicology exams that say, okay, well, it may not meet the criteria for this because I sent it to the lab, and the lab has some standard that does not, you know, actually recognize the concentrations that I submitted, but if I expose it to my redworms, they live very happily in it. So does it matter what a piece of paper with a bunch of concentrations, you know, does that matter to you, or does it matter that your worms stay up, you know? So we have to be better about that stuff.
Can I point out something about that?
Yeah.
Fall state? You know, remember mushrooms fruit when they run out of what? The food source. So you look at those piles and it's, you know, he added a lot of spawn to those piles. And if it didn't like, it could have not even liked the contaminant of interest. And it couldn't use it. It had no way to metabolize it. So what does it do? It responded by fruiting all over the place. So it was fruiting off of what? The spawn, right? I've got stuff that, you know, I've mixed it into some contaminated soil and it fruits immediately. That should be a warning to you. If it fruits immediately, it's probably not working.
I just got a report from a microremediation project from a mushroom farm. There was a spill on the ground. They sampled it, sent it to the lab, got the analytical back. Then they scooped it up, mixed it, broke it up into 3 different piles similarly, and then they treated it, and then they sampled each pile post-treatment, and they compared that post-treatment sample to the initial treatment. Does that make sense? Do you compare it, do you say you're successful if this one, you know, is lower than the one in the ground? No, because you went an extra step and mixed it up, and now you don't know if the first 4 or 6 inches compared to the, you know, foot down, if you mix that up, you may have diluted it, you may have done something, and you took a sample from the first 6 inches and you're comparing it to the post-treatment sample. How can you say it was successful? You know, so these are the things that I'm constantly seeing in these publications, in these experiments. So we have to be better about that. Open source publications. Now, this is more on the citizen science. Obviously, we're all here a community. How can we talk to each other? How can we get our experiments, such as my friend's mushroom farm report? How can I put that on my website and say, look, this is an awesome report, but these are the flaws in it. How can we learn from this? And make it available for people to look at the same thing that I'm looking at and have discussion and talk about it so that we can come up with better projects, better experiments, better steps to take, and better better ways to determine success.